Section 9.3, we're going to look at effective interest rates. What an effective interest rate is it's the amount of interest that we would get annually if we only had compounding once per year after compounding. So what we're looking at is we really have three rates. We had our formula that said I is equal to J over M. And in this formula we said J, this was the nominal rate. Well, that nominal rate, this is the posted rate. So it could be 5% per year. This is the amount stated, and we're going to put a compounding factor with it. This is the compounding frequency. So we always had statements that said this is 5% compounded monthly. And that's taking a nominal rate and a compounding frequency. And this could just be, say, 5% monthly. What we calculated out of that was our periodic rate. And what a periodic rate is, this is the rate that we get per month. So if we did this, this would be 5% divided by 12. Do a little calculation. 5 divided by 12, 0.4166. This would be 0.4166% per month. On a month-by-month basis, we're getting 0.4166%, which is the same as that 5% monthly. What we're looking at is the last value that we have is the effective rate. And the effective rate, this is what would be the equivalent rate for 5% compounded monthly, or 0.4166% per month on an annual basis. So what is the real rate after compounding? Okay. Another way to think of it is, what is the equivalent simple interest rate for a compounded rate? Well, we could do a simple little exercise on our calculator. And we could say, well, we could take a look at, say, $1 invested for a certain amount of time at, say, 6% compounded monthly. And we get a value here. And what we want to take a look at is what would be that equivalent rate if it was only one annual amount instead of 12 months. And instead of doing this as $1, let's do this as $1,000 so we can see the results. So if we have a present value, which is $1,000, we had an I per Y, which is our 0.5, which is our 6% over 12. Okay. We had an N, which was 12 because it's 1 year, compounded 12 times a year. And we're going to compute a future value, and we'll see what it comes out as. Note that if it was simple interest, this would be $10,000 or $1,060. At compound interest, we say this is $1,000 as a present value, 6 divided by 12.5 as our interest per year, 12 months as our N, and we're going to compute the future value to be not 1,060, which we'd have with simple interest, but we get $1,061.68. So the extra $1.68, this is the extra amount from compounding. If we were then going to calculate what the simple interest was, we would say that the 6% wouldn't be 6%. This we would relate to 6.168%. The extra $1.68 we get on $1,000 in a year. So in this case, we would say 6% compounded monthly is equivalent to 0.5% compounded, or sorry, not compounded, per month, say, on a monthly basis, our periodic basis, which is equal to 6.168% as an effective rate. Right? Or we could say that's 6.168% simple interest to get the same amount, or simply 6.168% compounded annually. Well, using a formula to get this, we say that our effective rate is equal to 1 plus I to the m minus 1. And that's really the result of what we had before, where we took, say, $1 and turned it into the future and figured out what the rate was. So we'll do the calculation again with 6% that we just did. We'd say our effective rate is 1 plus 0.0, well, it wasn't 0.06, it was 0.005, because remember this is an I, this is a periodic rate, to the 12 minus 1, and that's going to come out to 0.06168. Which is equivalent to 6.168%. The other way we can do it is we can do it using our calculator, and we use the special functions. So what we're going to do is we're going to first of all press the second function, and then we're going to press iConvert. Number 2, it says iConvert. This is the interest conversion function. And it has 3 values here. We have a nominal rate, we have an effective rate, and we have compoundings per year. So take a look at our nominal rate. We just are going to press 6 and go enter. So this is a 6% nominal rate. We're going to press the down arrow until we get to compoundings per year, and we'll say we're going to do 12 compoundings per year. Press enter. And then again, we're going to press the up and down arrow until we get to the effective rate. And now we're just going to press compute, and it's going to tell us the rate. So same as we had before, but now we're going to say second iConvert. This, then we're going to say the nominal rate is 6%. The compoundings per year are 12 times per year, and we're going to compute the effective rate, and it comes out to the same 6.168% that we've had all along. If you look at an effective rate, we're going to do one other example. And we can take a look at a department store credit card. And the credit card has, so the credit card has a rate of, we'll say 24%. when we look at this rate of 24%, we also notice on the credit card that outstanding balances are compounded daily. So what we want to do is we're going to find the effective annual rate. So in our problem here, we're going to say, well, our I is going to be, well, it's our 24% over 365, and we can calculate an I. Or we can use the values in our calculator. So calculate I this way. I will use the formula first. The effective rate is equal to 1 plus I to the m minus 1. So this is 1 plus 0.24 over 365 to 365 minus 1. Using the calculator, again, we're going to say second function I convert. Then we're going to set the nominal rate is going to be equal to 24%. The compoundings per year, this is going to be equal to 365. And we're going to compute the effective rate. So our calculator, second function, I convert. The nominal rate was 24%. The compoundings per year was 365. Press enter. The effective rate, we're going to compute it, and it's going to be 27.115%. So this effective rate is 27.115%. So even though the department store says that a 24% rate compounded daily, that's what they say, really what they're charging is 27.115% annually. So we say compounded annually.